Okay, this is a little different type of a podcast that I'm going to use to show one of the lessons, and it's lesson 1.5. So I'm going to go back and forth between the screen using Mimeo, but also, and I'll show you, just using some demonstrations here to help with this lesson. Traditionally, this lesson, lesson 1.5, in the past is a little bit harder to understand because it's more visual, and the only way that sometimes we can do this is to have a video showing some of these objects so you can get a better idea of what they look like. First of all, I'm going to switch the screen here, and I want you to take a look at this Mimeo screen. And what I want you to do is, first of all, just in your notes, write down the topic. And this is lesson 1.5, and the topic is called Postulates and Theorems and how they relate to points, lines, and planes. Now, so far you should kind of have an idea what a postulate is. And we're going to review that here in a little bit. But the new term is this thing called theorems. So to start with, let's start with postulates. And remember, a postulate is a rule. It's something that we don't need to prove. We know it's true. Just for example, in say a red light, we know that means stop. We don't need to prove that because it's a law or a rule. So what I'm going to do here first is I brought up the screen, and notice it has postulate 5, 6, 7, 8, and 9. And I'm going to go through these one at a time. So in your notes, I want you to pause this when needed, and I want you to write down postulate 5. Now in postulate 5 it says a line contains at least 2 points. Now to show that, it says a line contains at least 2 points. So what I'm going to do is I'm going to show you on a piece of paper, and I'm going to draw a line. So a line contains at least 2 points. So if I have a line, I can't have a line if I don't have more than 1 point, because this line could go, it could go that way, it could go this way. I could have a whole bunch of lines. So a line, I have to have, if I have 2 definite points, okay, notice that I've drawn 2 points, there's only one line that can go through that. And I'll show that. I'll take the ruler and I'll connect those 2 points. If I'm going to have a line, I have to have at least 2 points. It doesn't work if I have just 1 point. Now the other part of this postulate, it says a plane contains at least 3 points, not all on one line. So why does a plane have to contain at least 3 points? Why can't a plane contain 2 points? Let's go back to my picture here of the line. Now why can't a plane have just 2 points? Well, here's the reason. If I take this line, and I think you can see that, I could have a plane going through it like this, right? I'll tip it the other way, right? That would be a plane. But I also could have another plane that would go through it, go through those same 2 points, right? In fact, I could have numerous planes that go through 2 points. But if I have 3 points, say I make 3 points like that, there's only one plane that can contain those 3 points. And notice that on this piece of paper, that is one plane. So I need at least 3 points to have a plane. So a plane contains at least 3 points, not all on one line. Why can't they all be on one line? Same reason why if you had just 2 points, you could have numerous planes going through those 2 points. Just like if you have 3 points on a plane, or excuse me, if you have 3 points on a line, you could have numerous planes going through those. Then the last part of this is space contains at least 4 points. So let's take a look at my 3 points again. Now this is a plane, right? If I have at least 3 points not on one line, I've got a plane. I can create a plane. Now, why does space contain at least 4 points? Well, if I have, and let me go back to the definition here. If I have, let's see, space contains at least 4 points, not all in one plane. So, They cannot be all in one plane. So I have 3 points there, right? Now how about if I have and I'm going to use a little different demonstration. Take a look at the purple plane. Now if I had 3 points on here, 3 points would create a plane. They could create that purple plane. But if I have a 4th point not on the purple, say it's on the blue, now I've created another, I can create another plane. But if I have all 4 points on that purple, it's still one plane. So if I have 3 points on the plane, but 1 point off the plane, then that's what is considered to be space. All right, let's move on to the next postulate. And postulate 6 says through any 2 points, there's exactly one line. Through any 2 points. So if I have 2 points, there's exactly one line. What's this mean? Well, it means this. If I have, let's go back to my line that I drew down below. Okay, I have 2 points. 2 points we know make a line. Can I have more than one line through those same 2 points? That's a question I'm asking. Could I have more than one line through those 2 points? You might say yes, because yeah, you could take a ruler and draw another line, but it's the same line. So what this postulate is saying is through any 2 points, there's exactly one line. You can only have one line through those 2 points. Because all you're doing is if you drew another line, it's the same line. Postulate 7, through any 3 points, there is at least one plane. And this is kind of related to postulate 5, but let's read on. And it says through any 3 non-collinear points, exactly one plane. So through any 3 points, there's at least one plane. What's the difference between through any 3 points, there's at least one plane, and the statement that says through any 3 non-collinear points, exactly one plane? See, I'm going to highlight something here, and this is something you really got to understand. In the first part, it says at least one plane. The second part says exactly one plane. What's the difference? Well, here's the difference. If I have 3 points, yeah, I can have a plane. But here, I'm going to add another point to this line. So on this line that I have shown below, I have 3 points, right? Now, this line is on one plane, right? But could I do this? Could I take another sheet of paper, and could I put another plane through those 3 points? Yes, I could. In fact, I could put numerous planes through those 3 points. But what would happen if I have what it says in the other part of the postulate? Through any 3 non-collinear points. Non-collinear means they're not all on one plane. So I have 3 points. I'm going to back up. When it says 3 non-collinear, meaning 3 points not all on one line. So say I have 2 points, and then I have a point that's off the line, like this. So now I have 3 non-collinear points. Now how many planes would contain what I have drawn here? Just one. It's the paper I'm holding up. That's the plane. That's the only plane that could go through that line and that point not on the line. So there is a big difference between what it says with through any 3 points there's at least one plane, meaning that those 3 points are on a line, and you could put numerous planes through that line. And then where it says and through any 3 non-collinear points, exactly one plane. And here are my 3 non-collinear points where I can only have one plane. Hopefully that clears it up a little bit, and I haven't made you more confused. All right, postulate 8. If 2 points are in a plane, so let me demonstrate that. I'll draw that, and we'll come back to this. So up on this paper here, I have 2 points on a plane. The sheet of paper is the plane. Now it goes on to say the line that contains those points is in the plane. So I'm going to draw a line through those 2 points. Now this is kind of a common sense one. So if I have two points on a plane, then the line that contains those 2 points has to be on the plane. So the line that contains those points has to be on that plane. All right, postulate 9. If 2 planes intersect, the intersection is a line. We've talked about this one a little bit already. Now, what I have here is I have the blue plane and I have this purple plane. Now, if you can, I'm going to tilt it. Now, what's the intersection? Remember, a plane really keeps on going. So this purple, it keeps on going and going out that way, and it keeps on going and going out this way. It keeps on extending in all directions. Same thing with the blue. It keeps on going out, and it keeps on going back, and so on and so forth. So where do they touch? And I'll tilt this a little bit here. What is that intersection called? Well, since these planes keep on going, the intersection is called a line. All right? So what this postulate is saying then is that if 2 planes intersect, the intersection is a line. And hopefully that showed you a little bit better what that is saying. All right, I want you to write these 2 things down in your notes. We've already talked about a postulate. It's a statement that is accepted without proof. You know, Wednesday, the day of Wednesday is after Tuesday. We don't need to prove that. I mean, it is what it is. Now here is the new one, a theorem. A theorem is a statement that can be proved. So it's something that, hey, we're not sure if it's true. We're not sure if it's true, but maybe it is true. You know, we're just not sure one way or the other. So a theorem is kind of a, we're not quite sure what's going on with it. Maybe we can prove it, maybe we can't. Some things you can't prove to be true, and some things you can. So a theorem then is what we're getting into next. Now, I've got 3 theorems, and I'm going to take one at a time. The first one is theorem 1-1, and I do want you to pause this and write this down. Now, theorem 1-1 says if 2 lines intersect, then they intersect in exactly 1 point. To demonstrate this, and I'll just be able to do this right on the screen here. So if 2 lines intersect, they have to intersect in just 1 point. They can't intersect in more than 1 point. So in other words, this point right here, that's where they intersect. There's no way that they could intersect in more than 1 point. You wouldn't have a straight line. Maybe you could curve, maybe you're saying, well, I could take this line right here and curve it around so it goes through over here too. Then you don't have a line. Remember, lines are straight. Theorem 1-2, through a line and a point non on a line, there is exactly 1 plane. Now that sounds familiar because it actually, let's see, through a line and a point non on a line, there's exactly 1 plane. It kind of relates to one of the postulates we've already talked about. So if I take, I'm going to make a line, and there's a point non on the line. So in other words, I have, how many points make a line again? 2. So maybe that's a point, and that's a point. Now let me ask you this. How many planes could go through this line? Remember my demonstration before? If I had this line right here, how many planes could go through that? Well, just to emphasize that, I could have a plane here, I could have a plane here. I could keep on taking different sheets of paper and just turning them at different angles, and you'd have a lot of planes. But what this theorem is saying, if you have a point not on that line now, well, now I have 3 points that are not collinear, and there's only 1 plane that contain those 3. All right, the last theorem that we have, if 2 lines intersect, so I'm going to draw 2 intersecting lines. If 2 lines intersect, then exactly 1 plane contains those lines. Why? I want you to think about that. Why is there just exactly 1 plane that contains those lines? Why can't more than 1 plane contain those lines? Because what you have here, so we have for any line, how many points do you